Hello, welcome to 5.1 Exponential Functions and their Graphs. So we've seen functions in the form f of x equals x squared or x cubed or even x to the 1/3. Now these all are functions where you have a variable raised to a constant power. Now in exponential functions we're going to look at constants raised to variable powers. So an exponential function, let a, it's not Abe, let a be a fixed positive real number not equal to 1. The exponential function with the base a is a function f of x equals a to the x. So if it's 1 to the x, that's just always going to be 1. So that's really not going to be anything to speak of. But if it's like 2 to the x, you get this nice curve. Note, for any positive constant a to the x is defined for all real numbers of x. The domain of f of x equals a to the x is a set of all real numbers. You can plug anything in. Now the range is not going to be all the real numbers, but the domain will be. Also recall that for any non-zero number, a to the 0 is 1, so 0 can't be a base. A is a positive number, positive real number. This means the y-intercept of any exponential function that's not shifted. So if it's not shifted up or down, left or right, make sure I get the directions correct, then you have the point 0, 1. That is your y-intercept for a non-shifted function. There are two classes of exponentials, the base being larger than 1 and the base being between 0 and 1, or smaller than 1. So here are some values, for example. Okay, here's our x values. F of x equals 1/3 of the x. So this is the case where the base is between 0 and 1. And here's a case, g of x equals 2 to the x, where the base is bigger than 1. So f of negative 2, that's 1/3 of the negative 2 is 9. F of negative 1, 1/3 of the negative 1 is 3. F of 0, they should say, 1/3 of the 0 is 1. F of 1, 1/3 of the 1 is 1/3. F of the 2, 1/3 to the 2 power is 1/9. And here's the graph of these values. So the base being between 0 and 1, we see this going down, becoming smaller and smaller and smaller as x gets larger. The other side of this, g of x equals 2 to the x, where a base is bigger than 1. For g of negative 2, you have 2 to the negative 2, which is 1/4. G of negative 1, 2 to the negative 1, which is 1/2. G of 0, 2 to the 0, which is 1, not 0. G of 1, 2 to the 1 is 2, and g of 2, 2 to the 2 is 4. You see these are getting larger as x gets bigger, and this is a graph of the curve there. As x gets bigger, g of x gets larger. Okay. Let's talk about the behavior of exponential functions. Given a positive real number a not equal to 1, the function f of x equals a to the x is a decreasing function if a is between 0 and 1, with f of x going to infinity as x goes to negative infinity, and f of x goes to 0 as x goes to infinity. That was where it's coming down. It's an increasing function, it's getting bigger if a is bigger than 1, with f of x going to 0 as x goes to negative infinity, and f of x goes to infinity as x goes to infinity. In either case, the point 0, 1 lies on the graph of f. The domain of f is a set of real numbers, and the range is the set of positive real numbers. Now, this is for non-shifted. For non-shifted, it's from this point, it's either just above the x-axis on up, or up here going down to still be just above the x-axis. The x-axis is called a horizontal what? Asymptote. Yeah, it's a horizontal asymptote. It'll be approaching that, again, for a non-shifted function. So let's look at example 1. See if I can get both these on here. Okay. For example 1, g of x equals 0.5 to the x. You could also think of that as 1/2 to the x power. So if we look at x, look at g of x, we'll try like -3, -2, -1, 0, 1, 2, 3. 1/2 to the -3 power is going to be 2 to the 3, which is 8. Is that negative? 1/2 to the -2 power is going to be 2 to the 2, which is 4. 1/2 to the -1 power is going to be 2 to the 1, which is 2. 1/2 to the 0 power is going to be 1. 1/2 to the 1 power is going to be 1/2. 1/2 to the 2 power is going to be 1/4. And 1/2 to the 3rd power is going to be 1/8. So if we go with this graph here, -3, let's see if I'll keep it like it's scaled. -3 corresponds to 1, 2, 3, 4, 5, 6, 7, 8. -2 corresponds to 1, 2, 3, 4. -1 corresponds to 2. 0 corresponds to 1. 1 goes with 1/2. 2 goes to the 1/4. And 3 goes to the 1/8. So this is our curve, and it's getting smaller as x gets larger. Now in our next one, we could think of r of x as a shifted function. So if we said f of x is 5 to the x, r of x would be f of x minus 2, because it's minus 2, then plus 3. So r of x is the graph of f of x shifted 2 to the right and 3 up. So let's look at x, f of x. So we'll try, I don't know, -2, -1, 0, 1, and 2. So here we have 5 to the -2 is 1 over 25. 5 to the -1 is 1 over 5, which is 0.2. This one's 0.04. 5 to the 0 is 1. 5 to the 1 is 5. 5 to the 2 is 25. So now a lot of these are going to show up on this graph that we have. So I'm going to plot in red f of x, then we'll plot in orange r of x. Okay, so we have -2 and it's 0.04. It's way down there. And we have -1 is 0.2. And then we have 0 is 1. The 1 is 5. And then we're beyond the graph of 25 for the next one. So it's like this. So for r of x, we're going to go to the right 2 and up 3 for each point. So this point down here is going to go up 2 to the right 3. This point up 2 goes there, the right 3. 0, 1 is going to go up 2 to the right 3. And then 1, 5 is going to go to the right 2, then up 3. No. Yes. I think I had some of those off. That's going to be to the right 2, then up 3. There we go. I had that off a little bit. To the right 2, up 3. I said the right words, I just didn't do it. To the right 2, up 3. And then to the right 2, up 3. There we go. It's up here. So this is the r of x, and this is f of x. I'm going to go on to part C here. It says h of x equals 2 to the x. So here we go. Blue. Okay, here we go. I like the blue pens. H of x equals 2 to the 2x. So we'll go again with negative 2, negative 1, 0, 1, 2, 3. Here this is going to be 2 to the negative, to the 2 times negative 2. 2 to the negative 4, which is 1 over 16. 2 to the 2 times negative 1, which is 2 to the negative 2, which is 1 over 4. 2 to the 0, 2 times 0, which is still 2 to the 0, which is 1. 2 to the 2 times 1, which is 2 to the 2, which is 4. 2 to the 2 times 2, which is 2 to the 4th, which is 16. And 2 to the 2 times 3, which is 2 to the 6th, which is 64. Okay, so negative 2 corresponds with negative 1/16. Negative 1 corresponds with 1/4. 0 corresponds with 1. 1 corresponds with 4. 2 corresponds with 16. That's going to be beyond our graph. So, like that. Now, something else you could have done with this is treated this as h of x equals 2 to the 2x, which is 2 to the 2 to the x, which is 4 to the x. So we could look at it that way as well. Okay, I'm going to go on to the next page, our last page, so feel free to pause if you need to pause that. Our next part is solving elementary exponential equations. And this actually, we're going to do a little bit here. We're going to build on it as the chapter goes. And in the last section of this chapter, we're going to do a lot more of this. It's a lot of fun. So an exponential equation, and one variable is, as you might expect, an equation in which the variable appears as an exponent. In other words, an exponential function, or some variant of one, appears as a term in the equation. While exponential equations can become more challenging and consequently more fun, we will begin solving more basic exponential equations. Later in this chapter we'll get to try solving the more challenging type, but we need to develop some skills before we can do that. We'll be solving the type a to the x equals a to the b, where a is an allowable base for an exponential function. It's positive, not equal to 1. And b is a constant. The idea is to solve the equations to get both sides of the equation at the same base so you can equate the powers. So on example 2 here we have 3 to the 2x minus 1 equals 27. Well, we can express this as 3 to the 2x minus 1 equals 3 to the 3, because 27 is 3 to the 3rd power. So 2x minus 1 equals 3. 2x equals 4, so x equals 2. We can check this. Is 3 to the 2 times 2 minus 1 equal to 27? That's 3 to the 4th minus 1, is that 27? 3 to the 3rd is 27, so 27 equals 27. That works. In the next one, we have 7 to the x squared plus 3x equals 1 over 49. Well, that's 7 to the x squared plus 3x equals 1 over 7 squared. Or 7 to the x squared plus 3x equals 7 to the negative 2. So that x squared plus 3x equals negative 2. Bring the negative 2 over. X squared plus 3x plus 2 equals 0. That's going to be x plus 2 times x plus 1. So x plus 2 equals 0 means x equals negative 2. X plus 1 equals 0 means x equals negative 1. Now let's check those answers. Are they going to work? 7 to the negative 2 squared plus 3 times 2, is that going to be equal to 1 over 49? That's 7 to the 4th plus negative 6, is that 1 over 49? That's 7 to the negative 2, is that 1 over 49? Yes, it is. That works. How about 7 to the negative 1 squared plus 3 times negative 1? Is that 1 over 49? So that's going to be 7 to the 1 minus 3. Is that 1 over 49? 7 to the negative 2 is 1 over 49. Yes, it is. So x equals negative 2 and negative 1. I'm going to go on to the last part here, part C. So I'm going to have to erase it. Now for the last one here, 4 to the 3x plus 2 equals 1/4 to the negative, it should have been negative, not equals, negative 2x. So this is 4 to the 3x plus 2 is equal to 4 to the 2. See, it's 4 in the denominator now. Bring it up, change the sign. So we could say 3x plus 2 equals 2. That power equals that power. 3x equals 0 if I subtract the 2 from both sides. So x would be 0. So is 4 to the 3 times 0 plus 2 equal to 1/4 to the negative? Oh, I'm sorry. There's a mistake. There is a mistake. Back it up. That's equal to 2x. I forgot the x. Okay, now we can go on. Now if I subtract 3x from both sides, 2 equals negative x, so x equals negative 2. Now let's check that. Is it 4 to the 3 times negative 2 plus 2? Is that equal to 1 over 4 to the negative 2 times negative 2? 3 times negative 2 is negative 6 plus 2 is negative 4. That's going to be equal to 1 over 4 to the 4th power. 4 to the negative 4 is 1 over 4 to the 4th equals 1 over 4 to the 4th. That works. And if you want to go a step further, 4 to the 4th is, I think it's 256. So x equals negative 2. Well, that'll do it for 5.1. I hope you enjoyed this as much as I did. Send me your questions. I'll see you guys online. Thanks.